Hey guys, in this video I am going to discuss everything that you need to know about the IIT JAM exam for physics. In this video I will discuss about the eligibility, the paper pattern, the syllabus, important books and the weightage of different units. So just be patient and watch until the end. Maybe your all doubts will be cleared by watching this video. So let's start. So JAM paper, IIT JAM paper is conducted in the month of February every year. Actually, it is conducted in second Sunday of February. The forms are out in the first week of September, and it stays until mid-October, and the results are declared generally in the third week of March. So JAM paper is conducted for MSc, 4 semester MSc course, joint MSc PhD, MSc PhD dual degree uh, at IITs and IISc. So it is used for it is used to give admission into these courses that I mentioned above. So IIT JAM paper is conducted for 7 subjects. That's biological sciences, mathematics, physics, biotechnology, chemistry, geology, and mathematical statistics. In this video, I am going to discuss about physics. Let's discuss first about the eligibility. The subject from which you want to give the paper, you should have studied that subject in at least 4 semester in your undergraduate course. If you have studied any subject in at least 4 semester in your undergraduate course, then you are eligible to give JAM paper for that subject. Okay, that's one thing. And the second thing is that you can apply for more than one subject. That, as I've told, it is conducted for 7 subjects. You can apply for more than one subject, but you have to be careful that the paper should not coincide in the same slots, because all the 7 papers are conducted in 2 slots only, so it should not coincide, otherwise you will not be able to give the paper. So that was that was the eligibility thing, that who are eligible. Okay, now moving to the paper pattern. Now moving forward and see what is the pattern of JAM, IT JAM paper. Okay, for physics there are 60 questions. There are 60 questions are asked, and which consist of 100 marks, which consist of 100 marks. And the entire paper will be of 3 sections, section A, section B, and section C. In section A there will be 30 multiple choice question, and in which the from question number 1 to question number 10 will be of 1 marks, and from question number 11 to question number 30 will be of 2 marks. Only one option will be correct, and there will be a provision of negative marking in this section. For 1 mark question there will be a negative marking of 1 by 3, and for 2 mark question there will be a negative marking of 2 by 3. Okay, now moving to the section B, it is a multiple select question. In this section contain multiple select question. It means that one or more than one options can be can be correct, and you will get the marks only when you select all the correct answers. Okay, there is no provision of negative marking in this section. And all the 10 questions, there are 10 questions in this section, and all the questions will be of 10 marks, 2 marks, sorry, all the questions will be of 2 marks. Now moving to the section C, this section consists of numerical answer type question, which means you have to you are not provided will be options, you are not provided will be with options. You have to give the on answer in numerical. You have to give the answer in numerical. Okay. So all the in this question in this part question number 1 to 10 will carry 1 mark, and question number 11 to 20 will carry 2 mark. In this section also there will be no negative marking, and a virtual calculator is displayed on your screen for which you can use for calculations. Okay, so that was all about the paper pattern. That was all about the paper pattern. Now moving forward to the syllabus. Now see the syllabus part. So the syllabus of physics contains of 7 units. There is mathematical physics, mechanics, oscillation waves and optics, electricity and magnetism, kinetic theory and thermodynamics, modern physics, and electronics electronics. So let's discuss one by one the important topics from each unit. So there are 7 units. Okay, so mathematical physics consists of calculus of single and multiple variables, partial derivatives, Jacobian is important. Generally one question is asked every year or every alternate year. And imperfect and perfect integrals, Taylor expansion, and Fourier series also important. Generally one question is asked every year, just like Jacobian. Vector algebra, very important, because if you are good in that, that will help you in electromagnetic theory also. Vector calculus, multiple integrals, and all your theorems like Gauss divergence theorem, Stokes theorem, Green's theorem, and all that. Now next topic is differential equation, and the syllabus of differential equation is not much diverse, so you just have to study first order equation and linear second order differential equation with constant coefficient. And then at last there is matrices is also very important. And at last there is complex number. So that was all for the mathematical physics syllabus. Now moving to the mechanics part. So I am saying that this is the most important part of the syllabus. You have to study it very carefully. Why I am saying that you will get to know when I will uh, tell the weightage of questions that are asked from each unit, that I will discuss in the end of this video. Then you will get to know that why I am saying that this is the most important part of the syllabus. Okay, let's discuss what are the topics in mechanics syllabus. First there are basic thing like Newton's laws of motion and velocity, and you should be able to write the expression of velocity and acceleration in all the Cartesian coordinates, polar coordinates, and cylindrical coordinates, etc. Then you should have an idea about uniformly rotating frames, centrifugal and Coriolis force. Coriolis force is a very important one. This year also a question in MSQ type was asked in as is asked from was Coriolis force. And then motion and a central force is also very important. Then Kepler's gravitation, topics from gravitation like Kepler's law, gravitational law in field. Conservative and non-conservative force is also very important. Then center of mass, you should be able to find the center of mass for important quantities like hollow sphere, solid sphere, uh, plane lamina, and all that. You should know how to find the element and integrate it to find the center of mass. Then you should able to write the equation of motion for center of mass. Then conservation laws like conservation of energy and linear and angular momentum. Then you should also study about the collision. Collision is also important. Then you have to, then there are theorems like parallel and perpendicular axis theorem that are also very important, and you should also be able to find the moment of inertia for different objects. And at last there is some of the topic fluid mechanics. There is not much syllabus for from fluid mechanics, only you have to study like Bernoulli theorem important, and the equation of continuity is important, and like buoyancy is very important from uh, fluid mechanics. So that was all the course from mechanics. Now moving to the next topic, that is oscillations and waves. Oscillation and wave. Oscillation and wave. In this first in the oscillation part, you have to know how to solve the differential equation of simple harmonic oscillator and what is its solution. Then you should also have a study about superposition of two or more simple harmonic oscillators. Lissajous figures are also very important. Lissajous questions are asked from Lissajous figures. And then you have to know a study about damped and forced oscillators. You have to study how to form the differential equation for damped and forced oscillation, and what are its solutions, time period, energy equations, and all that for these. And then you should have also the idea about resonance. So that was part of oscillation. In waves, you should know about wave equation, and how to express the wave equation in different form, and traveling wave and standing wave in one dimension, energy density and energy transmission in waves, group and phase velocity, very important topic. Group and phase velocity is a very important topic. Every year one question is asked from this topic, group and phase velocity. And then sound waves in media, Doppler effect is also very important. Sorry, Doppler effect is also very important. So that was all for oscillation and waves. Then coming to the optics, there are two parts like ray optics and wave optics. The syllabus of ray optics is very small. You just have to study very basic. If you have a very clear of your basics of class 12th, then there will be no problem. So the topics of ray optics are Fermat principle, theory of image formation, thick lens, thin lens, lens combination is very important. So that is all for ray optics. And coming to the wave optics, first you should know about interference of light, like Young double slit experiment, and n slit interference, three slit interference for three slits, n slits. These are the important topic for interference. Then Fraunhofer diffraction is also very important. Then diffraction for in it, you have to study about Fraunhofer diffraction for single slit and Fraunhofer diffraction for double slit. Rayleigh criteria of resolution and resolving power, also very important topic. And then there is diffraction grating. This year a question was asked from diffraction grating, also very important. And the most important topic, I am saying again, saying that, insisting that the most important topic from wave optics is polarization. This is the favorite topic which is asked in every year from optics. Polarization, you have to study it very carefully. You cannot afford to leave this topic. This is a very important topic of optics. So that was all from the syllabus of oscillation, waves, and optics. Now moving to our next unit, that is electricity and magnetism. So quickly we see that first there is the part of electrostatics, in which you have to know about Coulomb's law, Gauss law, basic 12th standard. Then electric field and potential, and the boundary conditions that are important, electrostatic boundary conditions that are very important in this part. And the solution of Laplace equation for simple cases, that is also important. Then you should also know about the conductor, different properties of conductor. This year also question in MSQ type was asked from on the different properties of conductors. Then you should have a basic idea about capacitors, its equation for charging, discharging, and all that. Then polarization is also an important topic in electrostatics, and you should know the expression for volume and surface charges and all that. And one thing more, I want to say that you should be comfortable in the equations, comfortable with the, like Gauss law, you should be comfortable to write it in integral form as well as differential form. And one more thing, yes, if if for this electricity and magnetism unit, you should be very much good at vector calculus and all the theorems like Gauss divergence theorem, Stokes theorem, and you should be able to uh, solve. You should be able to express in cylindrical coordinates and spherical polar coordinates. If you are good in that, then half of your work is done in this unit. Otherwise, you are going to face problem. Okay. So now moving towards the magnetostatics part. In this, you all know that there is Biot-Savart law, Ampere's law, Faraday law of EM induction, self and mutual inductance, and all that. One thing that is new in this for like Faraday law of EM induction and self and mutual inductance is that you have to learn to express it in differential form. Okay, now moving, there is some basics of alternating current, simple DC-AC circuits with RLC component. You must know how the circuit will behave when different components of resistors, inductor, and capacitors are used. Now, displacement current. This is a very important topic. You cannot afford to leave this. Displacement current is a very important topic. Now, as I've already told, Maxwell equations. You must be write all the four Maxwell equation in differential as well as integral form, and you must know the meaning of each differential equation, what the each equation implies. If you know that, then it is very good for you, and you are going to gain some marks for that. And then plane electromagnetic waves, simple equation, how they, what are the equations of electromagnetic waves and all that. Then Poynting theorem is also very important. And reflection and refraction at dielectric interface, and how to find the transmission and reflection coefficients. And that's only for normal incidence. You don't have to bother about the oblique incidence and all that. You just have to consider about normal incidence. Okay, and at last you have to know about the Lorentz force. You already know, you would have already know that about all Lorentz force. And what is the motion of charged particle in electric and magnetic field, that when a charged particle is put into an electric and magnetic field, what is the trajectory of particle. You should also study about these topics. Now moving towards kinetic theory and thermodynamics part. First, you in the kinetic theory of gases, you should be uh, able to know about the velocity distribution, like root mean square velocity, average velocity, most probable velocity, and equipartition of energy. You should know about these things. Then specific heat for mono, di, and triatomic gases, and you should have about idea about van der Waals gases and equation of state. These things are important. And yeah, expression for mean free path, and the dependency of mean free path on different things. And so that was all for kinetic theory. And now moving coming to the thermodynamics. In thermodynamics, first law of thermodynamics is very important, and you should be able to apply first law of thermodynamics for various processes like isothermal process, adiabatic process. You should know about what will be expression for work done in isothermal process, adiabatic process, as well as isobaric process and isochoric process and all that. You must be able to apply first law. So that is very important in this thermodynamics part. And then you should be able to know about the different type of process like reversible, irreversible, and quasi-static processes. Second law in entropy, most important. Second law in entropy is the most important topic. Now Carnot cycle is also very important. Maxwell thermodynamic, you must learn you Maxwell thermodynamic relation must be in your mind, because sometimes direct questions are asked from this topic. And thermodynamic potential and its applications, and phase transition, first order phase transition, second order phase transition, and all that, and Clausius Clapeyron equation. That is all for thermodynamics syllabus. And at last, for statical mechanics, you should have a basic idea of ensemble, and you should know about the distribution functions of Maxwell, Boltzmann, Fermi, Dirac, and Bose-Einstein distribution, and how the particles are distributed, how to find the entropy for different distributions, and all that. That is sufficient for stat mech part. So that is all for the kinetic theory and thermodynamics syllabus. Now moving toward the modern physics part. In this part, first topic that you have to study is relativity. In this you have to study about the postulates of relativity, Lorentz transformation, length contraction, and time dilation. Very important questions are asked from this point. In 2018, a lot of questions were asked from relativity, so you can't ignore this topic. This is also a very important topic. And then there is relativistic velocity addition theorem, that is also very important. Mass energy and Einstein mass energy equivalence, you all are familiar with. So that's all for relativity thing. So this is also I can say that all the topic that are mentioned in the modern physics syllabus is very important, so you can't ignore it. I'm just telling it one by one, but you can consider all of the topics as important. Now moving forward, there is black body radiation, that's also important. Black body radiation, photoelectric effect, Compton effect, Bohr atomic model, X-rays, like these are very important topics. Wave particle duality, de Broglie waves and all that, uncertainty principle, and superposition theorem. So that was all for this part. And now moving to the quantum mechanics, you should be able to know to how to calculate the expectation values of different operators. And now you should be able to solve the Schrodinger equation for one dimension, two dimension, three dimensional box. And you should be know how to solve the Schrodinger equation for one dimensional harmonic oscillator, that is also very important. And reflection and transmission at step potential. And at last, you should have a knowledge about Pauli exclusion principle. So now coming to the atomic physics, you should be able to know about the atomic nucleus and mass and binding energy. That's only that is the only part that is asked from atomic physics. And nuclear physics, you have a basic idea about radioactivity and laws of radioactivity. Okay? For that you can refer your 12th class modern physics book. That is enough. No more questions are asked except from that 12th class level. They are radioactivity is very basic, is asked in very basic level in JAM exam. So that's all for modern physics topic. Now moving towards our last unit, that is solid state physics, devices and electronics. So the syllabus of solid state physics is very less in JAM. The most important topics are Miller indices, X-ray diffraction, and Bragg's law. Okay, you should also have idea about the crystal structure and Bravais lattice and all that. You just have to prepare only these topics for solid state physics. Generally one or two questions are asked from solid state physics. Now moving towards the semiconductor part, you should have idea about intrinsic and extrinsic semiconductor, and how the resistivity vary with temperature. That's also important. Fermi level, PN junction diode, IV characteristic of diodes, Zener diodes and in application, bipolar junction transistor, and its characteristic in common base, common emitter, common emitter, and common collector modes. And you should also have an idea about amplifier, single stage and two stage RC coupled amplifiers, and oscillators, very basic or simple oscillator, Barkhausen condition, and sinusoidal oscillators. Now the most important topics of oscillator that you can't leave is op amp. Op amp, every year one or two question will be asked in from op amp, that is fixed, so you can't afford to leave this topic. Op amp is very important. You should study it thoroughly about how op amp is used in inverting way, in non-inverting way, how a op amp is used as an integrator, differentiator, and all that. So that was all for the analog electronics. For coming to the digital electronics, you should able to convert one number system into another number system. Like this year also, there was a question in NET type in which we have to convert from binary to decimal number system. Okay, you should also have idea about the basic gates, their truth table and combination of gates, and at last you should have also idea about De Morgan's theorem. So that was all about the syllabus part. So we have seen thoroughly discussed the syllabus and the important thing that is there in the syllabus. One thing that I want to tell, that JAM especially asked question from the topics which you have not studied in 12th, means you which the topics which you have especially studied in your undergraduate course. Okay, now after discussing about the syllabus, now the next question asked is from where to study these topics, means what books to refer. So for books I want to say that don't refer more than one book for a topic. Just stick to a one book, and that one book you should choose. You don't have necessity to go for foreign authors. You have to choose a book which suits your style of learning. Okay, you don't have to means after seeing others you also think like I also have to refer foreign writer. No, don't. There's no need of it. There are also good Indian authors. Just stick to one book and completely cover it. Okay, so now coming to the book part. First, for mathematical physics, what I will suggest is, if you are starting from very basic, you can refer HK Das or Mariel Bose. Both of the books are very good. For in those who are not able to understand foreign writer, for them HK Das is very good, and Mariel Bose is also very good. And for vector analysis, you have to refer the Murray R. Special Shom series ki. This is also a very good book. Okay, for mechanics, the book that I will refer is, for mechanics, the book that I will refer is Kleppner and Kolenkov. That is an awesome book. It will take some time, but it is a book worth to read. As I have already told, mechanics is a very important topic, so you have to spend some time, and Kleppner is a book worth of reading. So, and you don't have to worry about Goldstein. No need to study Goldstein. You can also, if you are not studying Kleppner, then you can refer JC Upadhyay. But if you asked me, I will refer Kleppner. And one more book in Indian writer, if you are going to refer, you can choose between JC Upadhyay and AB Gupta. No need to study these books. Okay, so for mechanics, Kleppner, for if you are going to refer a foreign item, and otherwise if you are not comfortable with that and you have to choose between Indian writer, then choose between JC Upadhyay and AB Gupta. Now for the books for oscillation waves and optics. So for waves and oscillation, both N.K. Bajaj and Brijlal and Subramanian, both the books are very good. You can choose either one of them. I am saying that you can choose any one of them. Okay, so for oscillation wave, our job is done. For optics, I will refer Ajay Ghatak. That's a very good book. But if you are not going for Ajay Ghatak, then go for Big Hosh. But if you ask from me, I will say go to Ajay Ghatak. Okay, that's the book for oscillation wave and optics. Now moving to the EMT part. For electromagnet, for EMT, David J. Griffith is a must read book, just like I have told Klepner, just like I have recommended Klepner for mechanics. In the same way, David J. Griffith is most recommended for electrodynamics. It will also take some of your time, but it is worth to read. Okay, but if you are not going to refer for Griffith for some language problem, then you can refer to Big Hosh. Okay, there are only just two books, you can refer either of them. Okay, now moving to the next part, that is kinetic theory and thermodynamics. For kinetic theory, you can, for thermodynamics, refer Garg Bansal and Ghosh. That's a very good book. Or you can refer HP Rai and AB Gupta. But if you ask me, I will say go for Garg Bansal and Ghosh. And for StatMac, the syllabus of StatMac is not that much in JAM. So you can either refer from some internet or all that, or if you are go insist to refer, then I will recommend FREEF. Okay, now coming to the modern physics. In modern physics, for quantum mechanics, you can refer either S.A. Verma or David J. Griffith. Both the books are awesome. You can for quantum mechanics, you can refer either one of them. For modern physics, in which you if you want to refer only one book, for in which you will get all the topics, for if you want a single book, then I will refer Beiser, Arthur Beiser, Mahajan and Chaudhary. In this book, there is all the topics of modern physics, from X-ray diffraction, photoelectric effect, quantum. All the syllabus of the modern physics will be covered in this single book. Okay. Now for nuclear physics, there is given DCTL, but I will not recommend that, because the syllabus of nuclear physics is not that much in JAM syllabus. You can, for that you can refer YouTube videos or from Google. You can also, your job will be done if you refer from that also. Okay. Now solid state physics, as I have already told that the syllabus of solid state physics is very less in JAM, so you just have to cover some basics. So for that you can choose either of the books, either SO Pillai or Puri or Babbar. Both of the books are good. You can choose either one of them. And for electronics, if you want to refer a Indian writer, there is a book called VK Mehta, in from Ashchan publication. That is also very good, and it is also written in very basic language. So if you want to refer a writer, you can refer VK Mehta. VK Mehta. Okay, from Ashchan publication. And you can also refer B Ghosh. And if you want to go for a foreign writer, Bolset is very good for electronics part. Okay, that was all about the book, and I will again say that refer only one book for each topic and complete it to the whole. And one more thing, if you are in first year or second year, and you are just going to start your preparation, then you can first solve the questions from SC Verma or Erudov. That will make your foundation very good. And after that you can, some practice books are like Samvedna and Arihant. There is a book of Arihant publication, in which there are previous year papers, like 14 or 15 year previous year papers. So you can refer Samvedna and Arihant after that, after you solve SC Verma and Erodo. Or you can also, if you are like in your final year, or if you are just starting your preparation before 6 months of the exam, then I will suggest you to go through some coaching material books, because they have like their material is very specific to the paper pattern, so you can also refer to that. Now at last, let's discuss the weightage of different units. So the I as I have already told, the mechanics is the most important part, so you can see it yourself. Like mechanics, you can see in 2018 total 22 number 22 marks question were asked from mechanics, and in 2000 and in 2017 uh, 25 number questions worth of 25 numbers were asked from mechanics. Similarly, in 2016 19 marks question were asked from mechanics, like in 2015 20 marks questions were asked from mechanics. So you can expect 20 to 25 marks question from mechanics. So that's why I have told that this is a very important topic. You can't afford to leave it, and study it thoroughly. And I have also told about you the books. Now the second topic that is important about after mechanics is the electromagnetic theory part. So EMT part, you can see in 2018 15 marks question were asked from EMT. In 2017 18 marks question were asked from EMT. In 2016 12 marks question were asked from EMT, and in 2015 11 marks question were asked from electromagnetic theory. So you can expect anywhere between 15 to 17 marks question from electromagnetic theory. Now the next important topic is electronics. Solid state and electronics is also very important topic for JAM. Like 15 marks question were asked from in 2018, and 15 marks question were asked from electronics in 2017, and 17 marks question has come from electronics in 2016, and 20 marks question were asked from electronics in 2015 exam. So you can expect anywhere between 17 to 18 marks question from electronics. So as you can see, if you have prepared your mechanics, electromagnetic theory, and solid state and electronics, you have covered about half of the syllabus. Means about 50 marks question are asked from only these three topics. Okay. Now if you want to go for modern physics, you will see about 10, you can expect about 10 to 12 marks question from modern. And waves and optics is also very important. You can expect 13 to 14 marks question every year from waves and optics. And for thermodynamics, you can expect anywhere between 12 to 13 marks question. 11 to 13 marks question you can expect from thermodynamics. And from mathematical, you can expect anywhere between 11 to 13 marks question you can also expect from mathematical physics. So as you can see, all the topics are important. So if you have got time, so try to complete your syllabus. But if you are short in time, so you can like filter your preparation so that you can maximize your marks in the minimum effort. So that's all for this video, guys. The video have already been so long. So if still you have any doubt, you asked in the comment section. And if you have liked the video, give it a thumbs up, share it with your friends who are also preparing for the exam, and subscribe the channel if you don't want to miss an update in the future. Thank you, guys.